We're going to start 1.4. Just a reminder, these are linear functions that we're doing in chapter 1. We started out just basically talking about functions, but now we're specifically focusing on linear functions, how to graph them, what a standard linear function equation looks like, the slope-intercept form. We're going to talk about the slope-intercept form. We mentioned the slope-intercept form last time as well, didn't we? What's the form called? Or just say it to me. Y equals mx plus b. That's the standard slope-intercept form of an equation. So let me ask you a couple of questions before I jump into this next section. If I give you an equation and it's not in slope-intercept form, so what about, for example, if I give you an equation and it looks like this? If it looks like that, is it in slope-intercept form? No, it's not. It is not. This is called general form. We'll get to this. You'll see this pop up in a couple of maybe the homework section. Close that window. It'll pop up in the homework section maybe a couple of times. So I just want to make sure I showed you this because if you see it, I wanted you to be able to know what to do with it. On the previous homework, on the previous slide, did we have an equation like this that you had to find the x and y intercept? Yes, we did. I showed you how to replace the x with 0 and it'll find you to solve for y, then replace the y with 0 and solve for x. That's what we did with an equation that looked like this. But what if I want to know the slope of that particular equation? What if I want to know the slope for that equation? Can you tell me the slope is 3 just by looking at it? Say no. No. Why? It's not in the right format. It's got to have a y by itself, which means it's got to be in slope-intercept form first. So that's the first thing that we're going to look at in the first slide here is going to be the slope-intercept form of an equation. So that's what you see. M is always the slope and the B is always the Y what? Y-intercept. That's the point that crosses the which axis? The y-axis or the x-axis? It's the y-intercept, so it better cross the y-axis. If it's the y-intercept, it better cross the y-axis. Okay? Alrighty, so here's where I want to start. I want to make sure that you understand how to take an equation like this, 3x plus 4y equals 15, how to put it in y equals mx plus b form. How to put this equation into y equals mx plus b form. The goal here is to get y by itself. And usually I'm going to leave it on the left. I'm going to get y by itself on the left. So I need to move everything else that's over here. I got to get rid of this 3x and this positive 4 that you see. All of that's got to go away. So step 1, I'm going to subtract 3x from both sides. Alrighty, so now on this left side I have 3x minus 3x, which does what? What happens to the 3x minus 3x? Alright, that's gone. What's left over here on the left side is 4y equals, now here's what's important. How you write this part. Can I subtract 15 and this 3x? Say no. No. I can't. They're not like terms. The 15 doesn't have an x attached to it, so you can't subtract these two things. So now you just have to bring them down. But I usually will tell you to bring them down in the proper order. The term that has the x attached to it should come down first. It doesn't mean it's wrong if you write 15 minus 3x. But I want you to go ahead and start getting it in the y equals mx plus b form. So I want you to put the part that has the x attached to it. Write this part first when you go to bring it down. So I'm going to bring down negative 3x. Is that a positive 15 or a negative 15? Positive. So I'm going to put a plus 15. That's how I want you to write that when you bring it down. It's not wrong to write the 15 first, but I want you to already start to get the mx plus b in its kind of stage where it looks like it's going to be an mx plus b over here. That's why I wrote it like that. Now the goal is to get rid of the 4. What do I do to get rid of this 4? Do I subtract or divide? Divide. Why should I divide?
So you can get y by itself.
That is true. Why shouldn't I subtract then?
Because you need to divide on the other side.
I do. Because this is multiplication. So in order to get rid of the 4, if that's multiplication, you got to do the opposite of multiplication, which is divide. So there we go. So now we gotta divide everything on both sides by 4. So now we end up with y equals negative 3/4 x plus 15 over 4. That is y equals mx plus b form. So now with this equation, what's the slope?
A negative.
Negative 3/4. What's the y-intercept? 15 over 4. Can any of these be simplified?
I mean, it'll be a decimal.
It'll be a decimal, but if I want to leave it as a fraction, is it okay to leave it just like it is right now?
Yes.
Yes, it can't be simple. There's no number that goes into both 4 and 15 that divides into both 4 and 15 evenly. There's no number that divides into 3 and 4. So both of these fractions are perfectly okay for you to leave it just like it is. You don't have to change it to a decimal either. Alrighty? Thank you. Anybody else not signed in? Okay, so with that said, every time you get an equation that's in general or standard form, that's what you have to do to turn it into y equals mx plus b form. Anytime the x and the y are on the same side, you got to do this process. What if I have written the equation like this? I'm going to show this to you because sometimes you may have it in the homework written like this. Let me use it, what you already see here. What if this is what they started out with? I'm just rewriting part of the equation that we already had. What if that's what they gave you? Is that in y equals mx plus b form yet? No. So you still got to get y by itself. If they gave you this equation, it looks like this. You don't have a whole lot left to do, right? But you still got to get the y by itself if they gave it to you in that format. The goal still is, whenever we say we want to get it in y equals mx plus b form, get the y by itself. Do whatever you have to do to get y by itself. You okay with that? Okay? Alrighty, so with that said, you can see that's what we've been talking about in the first slide here. So you understand what M and what B mean. Here is real life. Everything in this class relates back to real life. So let's see if this makes sense to you. Linear equations are easy to associate with things that you get done at the house. So let's read and see what it says. First step is always what? Read the problem. All right, let's read it and see what we're talking about. A plumber charges $65 for a service call plus $30 per hour for each hour spent on the repair. Assuming his service call charges can be modeled by a linear function of the number of hours spent it should be on the repair, write the equation of the function. Write the equation of the function. So they just gave you something that happens at any of our houses. You could be paying for plumbing services, electrical services, yard work, whatever it is you're paying for. Do you pay them a fee to just come to your house and see what your problem is? Yes, they don't just come out for free and be like, okay, I know your pipe busted up underneath the house. You're going to get charged just a flat fee just for them to come and tell you what the problem is. That's what that $65 is. That's just to tell you your problem is whatever the problem is. Now, after that, if you decide you don't want them to do the work because you don't have the money right now, it's like, I'm not going to have the money till I get paid, so I'm going to need you to come out later. So you're going to pay the $65 and you're good. But what if you do want to get the work done? You're like, okay, it's $30 per hour. Can you see how that equation or function that you see written on the screen models what we just read in the slide? Always, you can do for every single problem that you pay for work to get done, you can model it like that when you're being charged per hour. So, every single time, the M in this particular case, you've got y equals 30x, because why did we write 30x? Based upon what the paragraph says, why did we write 30x? They said $30 per hour, so 30 times x, and x represents the number of hours of work that they did, plus the $65 flat fee. All right, so here is my rate of change. Is this the same thing as slope? Say yes.
Yes.
Yes, this is the rate of change, which is the same thing as the slope. So in the homework again, if they say what's the rate of change, you're gonna say $30 per hour. If they say what's the y-intercept, you're gonna say 65. We okay? All right. So now let's make up some more that you might have. Have you done anything recently that you paid somebody by the hour to get done at your house?
Yes, I did.
What?
To repair my washing machine.
Okay, did they charge you a flat fee and a rate?
Yes.
What was the Y-intercept?
$90.
$90, and what was the hourly rate?
Oh, God, what did it break it down to 90? I guess it was about $40.
$40 per hour,
Yes.
done. Okay, so this is to repair washing. Okay, what else did you get fixed? Could have been this month, last month, a year ago. What did you get fixed? You had a car repair? Okay, let me use mine. I just got an alternator replaced yesterday. Okay, so again, parts and labor, right? Labor would be which one? Labor go here or here?
No,
Labor is the
labor
rate
is the
change.
rate.
Rate of change, because they're going to charge me however long it takes them 2 hours to do the alternator. That was 2 hours. So again, I had a flat rate, and usually they've already added your flat rate in. But the rate, let me make sure I say this right. My hourly rate was here, which was for labor, so I'm just going to write the word labor for now. And over here was parts, right? Don't try to pay for the parts. They don't give them to you for free. So again, what's the alternator usually cost? My full payment was $275. That was what I paid total.
When you said alternator cost 75.
So, so if my alternator was 75, and however, if it was 2 hours, so I paid how much per hour? Done. That's what I paid to get my alternator replaced. So you can see how that's the same. You could do this with just about anything. Does that make sense? This works for anything that you actually pay an hourly fee to get something done. So you can make up your own. It could be, like I said, it could be electrical work. It could be you getting your yard work done. You still got to buy materials to get your yard work done, and then they're still going to take some time to do your yard work. Sometimes, in general, you just might pay a flat fee, just depending on what you're getting done. But still, can you see how this relates back to real life using linear functions? Yes. Yes? No?
Yes.
Yes? Okay. All righty. So, next slide. Here is a new equation. Here is a new equation. The previous one was y equals mx plus b. Here is a new one called the point slope formula. The point slope formula. So here is the new equation that you know, that you're going to need to know. Are you going to need this for a test? Say yes. Yes. Does that formula look familiar to you? Just in some way, does it remind you of something? Yes. What formula does it remind you of? I heard it. Does it remind you of this one? Yeah. They just reorganized it and it became this. So if you move these things around, that's where they got it from. So it was derived from here. Okay? So again, this is your slope formula. This is called the point slope formula. So in order to use it, guess what you're going to need? What's it called again? So you're going to need a point and a slope in order to use this formula. What's the m represent again? Okay, so I'm going to need to replace m, so I'm going to need a slope, and I'm going to need a point. Now, I label one of these x1s and y1. That's your point. So I'm going to have to need a point, so I'm going to plug in a number for x1 and a number for y1. So in order for you to do the work associated with this problem, they have to, when I say they, I mean the homework has to give you enough information so you can have the slope and the point. You gotta have enough information for you to be able to figure out what the slope and the point is. They gotta give it to you. It's required. All right, so let's try this first one that they want us to do. It says write an equation for the line that passes through the point, -4, and has a slope of 1/4. Now, whenever they say they want you to write an equation, what you think they want it to end up looking like? What you think they want it to end up looking like? What does your final equation have to look like? Y equals mx plus b. That's your goal. You gotta get it to the point where it's in the y equals mx plus b form after you figure out what your point and your slope are. So let's do what they did. All right, they gave us a point. What's my point?
-4,6.
All right, -4,6, and I'm gonna name them x1 and y1. Okay? What was my slope? My m they gave me for slope. Equals to 1,4. All righty. So all I'm gonna do is plug those numbers in. All right, so y1 we said is 6, and m is 1,4, and x1 is -4. Alrighty, everything else I'm just gonna bring it down. That's in red that I didn't have to figure it out. It was already there. Those don't change. So bring down y and the minus sign, the equal sign, your parentheses, your first x, the minus sign, and the following parentheses. So I just dropped everything else that I didn't have to replace. Now my goal is to solve and get y by it. That's what I'm gonna do, because once I get y by itself, is it gonna be in this y equals mx plus b form? Yes, it is. That's our goal. So I'm just gonna start doing some math here. So I'm gonna add steps that you may or may not need. Did you notice in there they didn't add some extra steps? So I'm gonna add some extra steps here. So here is 1,4, parentheses, here's the first step I'm gonna add. You already know this, so you don't have to, you can skip this if you want to. A negative and a negative turns into a? So this is gonna be x plus 4. I know I'm doing extra steps, but it's okay. That was the first step I did. Next step, let's now distribute, which says multiply 1/4 times everything in the parentheses. So I brought down y minus 6 again. 1/4 times x, is that just 1/4 x? Yes. What's 1/4 times 4? Okay, can you see this? Okay, now sometimes you can choose to put a 1 underneath here so that you have two fractions and you just multiply across the top and across the bottom. It's up to you whether you want to put a 1 there or not. If you see it and you're like, I don't need to put no 1 there, I see the 4 cross out 4. 4 into 4 is 1, right? So I'm adding steps that you don't necessarily have to do. You could have actually just left it like this and say that cross each other out. So I'm gonna go back and put it like, just so you can see the steps the way I did it originally. So that's a 4, that was a 4. I put a 1 underneath there. I'm gonna go to my next step. All right, so I'm just literally gonna multiply across the top and across the bottom. What's 4 times 1? 4, and what's 1 times 4? 4. All right, extra steps that you don't have to do. I'm just simplifying little piece by piece. What's 4 divided by 4? 1. Alrighty, my goal is to get y by it. What should I do over here to get rid of this minus 6? You always do the opposite. So if it's minus 6, we're going to add 6 to both sides. So now this minus 6 and this plus 6 cancels out, right? So now I end up with y equals 1/4 x plus 7. Is it in y equals mx plus b form? Yes, it is. That's the equation for the point and the slope that they gave you. You now have an equation for a point and a slope. So now you can see how they skipped some steps. Can you see where I put the additional steps in? Okay, now for test purposes, if you wrote it and you skipped some steps like you see on the slide, perfectly fine. That's perfectly fine. I always like to make sure I add steps in so you know how I did every single thing. Questions? You're good? Okay, all righty. Next slide. Look at this one. In this particular slide, they gave you what? 2 points. They said write an equation of the line that passes through those 2 points. Wait, what did we say we needed in order to use that equation over there? What do we need? A point and a slope. Okay, so let's see. I need a point and a slope. I'm going to write my equation again. Y minus y1 equals x times x minus x1. And I need a point and a slope. All right, and I need a slope. All righty, what do I have that they gave me in the original equation? In the original sentence. 2 points. What are the 2 points? Negative 2 comma 3, and what else? 4 comma 7. Alrighty, should I go ahead and label them? Sure. So I'm gonna call this one x1, y1, this one x1, y2. Excuse me, I'm gonna call the first point negative 2 comma 3 is gonna be x1, y1. And the point 4 comma 7 is gonna be x2, y2. They give you 2 points, you should label them. Did they give me the slope?
No.
Is it possible for us to figure the slope out from the information they did give us?
Yes.
Yes, what should I use? Yep, I gotta come over here and use my slope formula. So I'm gonna use my slope formula since they gave me 2 points, and I'm just gonna plug them in. Y2 minus y1 over x2 minus x1. Let's plug them in and see what we get for slope. Alrighty, so y2 was 7, y1 is 3, over x2 is 4, minus a minus 2 for x1. Alright, let's simplify. What's 7 minus 3?
4.
Okay. On the bottom, I've got 4 minus a minus 2. That becomes 4 plus 2?
Yes.
Okay. So that's going to be 4 over 6. Can I stop there? Should I simplify that fraction? What should I simplify this to? 2/3. How did you get that 2/3? Divide each top and bottom by 2. That 2 is called your greatest common factor. So we divided the top by 2, and we divided the bottom by 2, and we get a slope of 2/3. So there's my slope. So that's what I'm going to put over here. Slope is 2/3. All righty. So now, do I have a point in the slope? I got extra point. So I can use, when it comes to the points, you can use whichever one you want. But I'm going to use the ones that I already labeled as x1, y1. Because in the formula, look at the formula, it has x1 and a y1. So I'm going to use the ones I already labeled. But it doesn't matter which point you choose to use. All right, so now let's go ahead and fill in my point slope formula. So now I've got y minus, y1 is a 3, and my slope is 2/3, and my x1 is a negative 2 here. All right, so now I'm gonna fill everything else back in as x minus, and I've got an equal sign. All right, I'm gonna follow the steps that I did before. So same steps, I got y minus 3 equals 2/3. Minus minus, notice I got x minus a minus 2, that's going to become x plus 2, right?
Yeah.
Alrighty. Next step, distribute, which means multiply 2/3 times everything inside the parentheses, which is going to give us 2/3 x plus 2/3 times 2. Can I put a 1 under that too?
Yes.
Okay. All right, let me move this out the way a little bit. All righty, so now I have, doing the next line, I've got y minus 3 is equal to 2/3 x. Now, I've got plus 2/3 times 2. I'm going to multiply across the top and across the bottom. Across the top is 2 times 2, which is?
4.
And across the bottom is 3 times 1, which is?
3.
3, okay. All righty. You okay so far?
Yeah.
Okay, all righty. Do I have y by itself yet?
No.
No. All right, let's get y by itself. I have y minus 3, so what should I do? Add or subtract 3? Add 3 to both sides. I'm going to add 3 over here and 3 over there. Whenever you look at your papers, all your equal signs should be lined up. They should come all the way down the page in a straight line, your equal sign. So you can make sure you got what's on the left side and what's on the right side should look like it's supposed to. Alrighty, so now I've got y by itself because the minus 3 and the plus 3 cancels out. I've got 2/3 x, so that's y equals 2/3 x plus, whoa, you got some fraction work to go do on your scratch paper. So on your scratch paper, you now have 4/3 plus 3. I'm going to put a 1 under that 3. I need a least common denominator, which is, what's the least common denominator between 3 and 1? 3. Okay, so I need both of these bottom numbers, these denominators, to be a 3. So I'm going to multiply this one by a 3. What you do on the bottom of a fraction, you always have to do on the top. So if you multiply, anytime you multiply a bottom number on the fraction, you always got to multiply the top by the same number. We're trying to get a common denominator here. We want both bottoms to be exactly the same. So now I have 4/3 plus, what's on top of this second fraction? 3 times 3 is 9 over 3. Do they have like denominators now?
Yes.
Now just add the top numbers together. So 4 plus 9 is 13. So now back over here to your equation, y equals mx plus b. B is 13 over 3. You are now done. Is it in y equals mx plus b form?
Yes.
Yes, it is. Now, what's the difference between this one and that one? The first one we did over here and this one over here. What's the difference between those two?
They gave us 1 point and they gave us slope.
Okay, so I'm saying this because in the homework they're going to give you some different things. So in this one, they gave us a point and a slope and you just plugged them in. And you didn't have any fractions that you had to find common denominators for. Over here, they gave you 2 points. You had to go find the slope. You calculate the slope yourself. And you ended up having a fraction and a whole number that you had to find the least common denominator and do some extra math on the side. You're going to have both of these types of problems in homework. Okay? We okay with this? They did the exact same thing in the slide that you see here. And we got the same answer that's on the slide. Do you see extra steps in here? Yeah. I mean extra steps from what you see on the PowerPoint as opposed to what I added on the screen here, on the white screen, on the whiteboard.
Yes.
Yes. All righty, ready? All right, do you need to practice this? You gotta practice it. And every time you use that formula, what 2 things do you have to have? A slope and a point, or a point and a slope. You gotta have them. And they have to give you enough information for you to be able to figure those out. Okay, you okay? All righty. So now let's look at the next slide, which talks about horizontal and vertical lines. Now those are the easiest 2 to create an equation for. It's going to want you to write an equation of every horizontal line and every vertical line. These are the easy ones to do. So, I still don't have. I don't know why I hadn't remembered to bring a thing in here, an eraser. All right, so here we go. I'm going to make a horizontal line on the graph. And I want us to be able to create the equation of the line. I need the equation of the line for a horizontal line. So here's my graph. You see one on the screen. I'm just creating one so I can write here so you can see what I'm writing. Alrighty, so here is my x-axis. Here's my y-axis. And I'm going to create one horizontal line. 1, 2, 3. Here we go. I want to know the equation of that line. Okay, let me show it to you in y equals mx plus b form so you can see. You can't do the vertical line like this, but you can do the horizontal line like this. Do I need an m and a b? Yes, in order to use this, you got to have an m and a b. Well, what's the slope of every horizontal line? 0. Okay, well, I can go in here and replace that with a 0. And what's the b for again? The y what? Where does it cross the y-axis? Where? They cross it at 3. Remember, this number is always going to be the number where it crosses the y-axis. Always, 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 always. So now, all I got to do is simplify it. Can I leave this as 0x plus 3? The computer going to think you didn't simplify it if you leave 0 times anything. What's 0 times anything? Okay, so 0 times x is 0. And you can't leave it like 0 plus 3 because 0 plus 3 is how much?
3.
That's the equation of the horizontal line, y equals 3. So let me give you the shortcut for this so that you don't even have to go through and do this process every single time. What axis does it cross? What axis does it cross? Okay, so I'm just trying to make sure you can listen to, making sure you understand the question that I'm asking you for a second. All right, the red line, what axis does it cross? Where does it cross it at? Done, that's the equation. For every horizontal line, you ask yourself, what axis does it cross? You say Y. Where does it cross it at? Whatever that crosses at, that's the number that you put. So, here's another horizontal line. What's the equation for this horizontal line? Done.
So what if it crosses the x-axis?
Okay, so hold on. Let's do this one. This is -1, -2, -3, and -4. What's the equation of this horizontal line? Done. These are what kind of lines again? This is the equation for any horizontal line. It's just going to be y equals a number. And that number is always going to be where it crosses the y-axis. All day, every day. So, this, yep, horizontal line, slope always equals 0. Always, always, always. So then, here is the other one. Well, let's look at vertical lines. So now we only did horizontal lines. Now let's look at the vertical lines. So now I'm just going to draw a separate XY axis. So now here is my X, my Y axis. Here's X, here's Y. All right, 1, 2, 3, 4, 5. Here's my vertical line. You can't use the y equals mx plus b. Why? There ain't no slope. You can't even say 0. There is no such thing as a slope of a vertical line, so you can't use this. So we got to go back to our shortcut. What's our shortcut? What axis does it cross? And where does it cross it at? Y. Done. That's the equation of that vertical line. All right, let's put one over here on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. There's my vertical line. What's the equation of that vertical line? Well, a -9. Thank you. That is a -9. So all you ask yourself is, what axis does it cross? It crosses the x-axis, and it crosses it at -9. Done. These are for vertical lines. And there is no slope. Okay, so does this feel comfortable for the horizontal vertical lines? Those are the easiest equations to write. Out of everything that we just did on the previous board, those are the easiest ones to create. So yeah, let me push this other board up just in case y'all still wanted to see that one. All right.
You did say that undefined is the same thing as no slope.
Correct. And let me put that up there so you can see. This also means undefined.
It's in the homework.
Mm-hmm. Yep, no slope and undefined mean the same thing. All righty. So we okay? Next slide. Parallel and perpendicular lines. What does the first bullet say? It says two lines that have the same slope are parallel. Well, doesn't that make sense? Look at it for a second. If you got a line that looks like this, and I draw another line that looks exactly like this, wouldn't you say they both got the same slope? They do. Two parallel lines have the same slope. All righty. What about perpendicular lines? Perpendicular lines cross at a 90-degree angle. They cross at a T intersection. So let me draw two so you can see what I mean. Here we go. And when I say a 90-degree, it has a little box there that tells you that it's a 90-degree angle. Now here's my question. One of these is uphill and one is downhill. Which one is the uphill line? Let me name them. This is line number 1, and this is line number 2. Which one is the uphill line? Is it slope positive or negative? Aha, so this one has a positive slope. Look at the downhill line. It is what? A negative slope. So this one has a negative slope. So when you do perpendicular lines, they're always going to have opposite slope. One's always going to be positive and one's always going to be negative because one is going to be going downhill and one's going to be going uphill. You got it? So let me write here. So this one is, line 1 is uphill. Line number 2 is downhill. Alrighty? It looks like an X. Okay, now, question. Are these the same thing as what I just drew? Say no. Look at what I just put up here on the board. Look at this one. Are these perpendicular lines? They are not. So you cannot use the same thing we just said for these two. These do make an X, but those X cross at a 90-degree angle. These do not cross at a 90. They are not perpendicular. So don't think these are not perpendicular. They definitely look like an X, but not perpendicular lines. Alrighty? So now, when you have two lines that have the slope, that they're perpendicular lines, their slope are going to be inverse opposites. It just means one's going to be positive, one's going to be negative, and you're going to have to flip it upside down. So, let me say this. For perpendicular lines, if the slope of one of them is, the slope for the first one is 2/3, what do you think the slope of the second line is going to be? It's going to flip it upside down, change the sign. If the slope for line 1 is 2/3, it's got to be negative. The other one got to be negative. And you have to flip it upside down. So slope is 2/3, then the inverse slope will be a -3/2. That's for two perpendicular lines like what you see here. The slopes are going to be inverse reciprocals of one another. That's reciprocal means flip it upside down. Okay, let me give you a different one. What if my first slope happens to be 3, then what's my second slope going to be for perpendicular lines? Aha, so you got to remember to put a 1 and turn this into a fraction. If it's a whole number, you got to turn it into a fraction first. So then my second slope is now going to be what? -1/3. Just got to remember, if you're given a whole number, you got to turn it into a fraction before you can flip it upside down. All right, we okay? All right, because we're getting ready to use this, so that's why you need to know this part. You need to use this in a second. All righty. Now, we talked about this equation earlier. It's in general or standard form. Did we use one like this before? Remember, I gave it to you on the first, when I first wrote the first part of the board, I gave you 3x plus what? You remember what it was?
3x plus 15.
Yeah, 3x plus 4y equals 15.
Thank you. All right, I gave you 3x plus 4 equals 15, so I'm going to go ahead and erase this away so you can see what we're talking about. So now you see general form, general and standard form mean the same thing. It could say general form, it could say standard form. It's the 3x plus 4y equals 15. When it's in general or standard form, the x and the y will be on the same side of the equal sign. When it's in general or standard form, the x and the y will be on the same side of the equal sign. Now, we walked through how to get y by itself, so if you see it like this, what you're going to have to do again? You got to do the work to get y by itself, just like we did on the previous slides. Alrighty? This is just to make sure you understood what the form looks like. So, here we go. Now it's time to do some work associated with that. So, you have an equation. It says, write the equation of a line that passes through the point and is parallel to another line. All right, wait a minute now. Hold on. Let me think about this for a second, because I want to make sure you're okay with what we're doing. All right, so let me stop. It says write the equation of the line. Anytime you see the phrase create the equation, write the equation, find the equation, you've got to use this formula. Which formula you think I'm gonna write up here? This one. What's it called again? This is called the point slope formula, and what do you need in order to use it? A point and the slope. Okay, well let's see what they gave us. What did they give you? Do you have a point?
Yes.
All right, what's the point?
Negative 2 times 3.
Can we label it x1, y1? All righty, so I got what I need to go here and here. What else do I need to use that formula?
The slope.
I need the slope. So what else did they give me? They gave me an equation. Can I tell what the slope of that equation is by looking at it?
No.
No, because it has to be in what format?
Y equals x plus b.
Okay, so if given an equation, make sure to put it in what form? Wait. If they give you an equation so you can find the slope, what do you have to put it in?
Slope.
You got to put it in y equals mx plus b form, which is the point slope, which is the slope-intercept form. Okay, if given an equation, put it in y equals mx plus b form. Make sure if it's already in there, you're good. But if it ain't in y equals mx plus b form, you got to put it in there. All right, let's do the work and put it in the right form. So I've got 5x minus 2y equals 8. My goal is to get the y by itself. When it says put it in y equals mx plus b form, it just means get y by itself. That's what this means, get y by itself. Alrighty, so let's start. What you want me to do first to get y by itself? Minus what?
5.
Minus 5x from both sides. Alrighty, so over here on the left, 5x minus 5x, does that disappear?
Yes.
Okay, so now what's left on the left is a negative 2y equals, how should I write what's on the right side? Negative 5x. Always put the term that has the x attached to it first. So now I'm going to write negative 5x. Is that a positive 8 or a negative 8?
Positive.
So I'm going to put plus 8. Do I have y by itself yet?
Yes.
Not quite.
No.
So now I'm going to what? Divide everything on both sides by what? Negative 2. Alrighty, so I've got divide that by negative 2. Divide this by negative 2 and divide this by negative 2. So the negative 2's on the left side cancel, and I end up with y equals, what's negative 5 divided by negative 2? Positive 5 over 2. All right, so I've got positive 5 over 2x. And now I've got a positive 8 divided by a negative 2, which is negative 4. Is it in y equals mx plus b form?
Yes.
Can you tell me what the slope is now?
Yes.
The slope is, so now I can say, because I had a question mark for my slope up here. So here my slope was up here, and we had a question mark because we didn't know what it was. Now we do. The slope is what? Equals 5 over 2. Now, go back and look what it says. What kind of lines are these that we're talking about? Perpendicular, parallel? Parallel. So what do you know about parallel lines with their slopes?
Yes.
They are the same. So do I need to flip this upside down and change the sign? No, because we got parallel lines going on, so don't change the slope. Leave it just like it is. So now I'm going to take these numbers that we now have enough to do the point slope formula, and I'm just going to plug them in and do the steps that we did before. So now in the place of y1, I'm going to put a 3. In the place of x1, I'm going to put a negative 2. And my slope is 5 over 2. And I'm just going to bring everything else down. All right, so this was 1 minus 3. Let me put this in red. I like this in red so it stands out. This was a 3. This was a 5 over 2. And that was a negative 2. All right. Equals... Alrighty, following the steps, now I've got y minus 3 on the left side equals 5 over 2 times x. Now let me go ahead and add the steps I usually would add in here. I've got an x minus a minus 2, which becomes x plus 2. Okay, so x plus 2 goes here. Now let's go distribute that 5 times x, 5 over 2 times x. Let me put a red arrow here. 5 times 2 times, 5 over 2 times x and 5 over 2 times 2. All right, so this is going to be 5 over 2 times x. Now I got 5 over 2 times the 2. Should I put a 1 underneath here? It's up to you. You may see it as, well, I can just cancel these two 2's because one's up top and one's down bottom. Totally up to you how you choose to do that. All right, so I'm going to simplify a little bit more. Brought down my y minus 3 on the left side. On the right side, I've got 5 over 2 times x plus. I'm multiplying across the top and across the bottom. What's 5 times 2?
10.
10. And 2 times 1? 2. All right, let's keep simplifying. All right, what's 10 divided by 2? Done. Almost. I said done too fast. What should I have to do now? What do I have to do now? Is y by itself?
No.
What should I do?
Add 3.
Add 3 to both sides to get rid of this minus 3 on the left side, so I got to add 3 on this side. The negative 3 and the minus 3 on the left cancel, so now you have y equals 5 over 2x plus 8. Now we're done. So, now, let's go back over it and make sure you understand. In the very first one we did with that point slope formula, they gave us the point and the slope. And we just plugged it in and got y by itself. Right? In the second one, they gave us 2 points. And you had to calculate the slope and then plug in one of the points and the slope. In this third type, they gave you a point and an equation. And you had to rewrite the equation to get y by itself, then pick the point and figure out what the slope was from the equation to use. So you see that they can give it to you in several different ways? This is what you're still going to see in the homework. So you got to know if they give you the point and slope, easy, plug them in, do the math. If they give you 2 points, calculate the slope, then plug them in, do the math. They give you an equation, make sure you write it in y equals mx plus b form so you can see the slope before you start plugging things in. Question? I'm stopping to make sure there are any questions. What questions do you have? Really, it's just remembering what you're given and what you got to do. Are you going to have to use y minus y1 equals m times x minus x1 as long as it says write an equation?
Yes.
Yes. Yes. I'm sorry. Go ahead.
You-
Well,
So, the reason they gave us that equation was just to give us a slope, right? Because it's parallel.
so you didn't know the slope until you had to rewrite it in this form so you would know the slope.
But if it didn't say, I'm sorry, pardon,
I just changed the slides on you.
oh, okay.
To go back a slide, there's the one that said parallel.
So if it didn't say parallel, then we wouldn't be able to use that equation, right?
Correct. So, well, we have to change it. We still got to rewrite it. So let's go to the next slide, which is why I push the slides up. Because now, look at the difference between the previous slide and this slide. What's the only difference between the previous slide and this one? Now we need a different slope. Yes, ma'am.
I want to go back and ask, you said whenever we see write an equation,
Correct.
then we use the point slope
Formula. Yes.
formula. Okay, that's,
The only time that you don't have to do all this extra math is when it's a vertical and a horizontal line. Remember, you don't have to do none of this for the horizontal and vertical line. But for everything else, yes, you have to do this point slope formula stuff.
but only when it says write an equation.
Correct. It's going to say write the equation, find the equation, create the equation.
So anytime we see equation, we go to the point slope.
Mm-hmm.
Okay.
Absolutely. There was another question. Was there another question? All right, good. So now that you see the new slide, it's the same equation, but now instead of a perpendicular line, we're trying to find instead of a parallel line, we're now trying to find the perpendicular equation for the perpendicular line. All righty? So, do I still need to use my point slope formula? Say yes.
Yes.
Do I still need my x1 and my y1? Say yes. Do I still need my slope? Say yes. Now here's the question. Can I keep this slope that we already did the work to get y by itself because it's the same equation. Do we need to go back and redo this work all over again? No. Can I use this same slope that I have? If it says perpendicular, can I use the same exact, meaning do I have to do anything to it? I do have to do something to it. What should I do? Flip it upside down and change the sign. That's all you have to do. If it asks you a perpendicular line, you gotta flip the slope upside down and change the sign. Alrighty, so let me write this one on different board. So let me switch boards here. Push this one up. Pull this one down. Alrighty, so now I'm gonna actually use the exact same point slope formula. Plug in the points, and I'm gonna plug in a slightly different slope. Okay, so here is my y1 minus y2 equals m times x minus x1. Alrighty, so my new slope, what's my new slope now? Negative 2 over what? Are we using this one right here? Yeah, remember the equation is the same. We didn't change the original equation. Can you see we're still using that 5x minus 2y equals 8? So we already know that the original slope was 5 over 2, but I need the perpendicular slope, so you gotta flip it upside down and change the sign. So my new slope is gonna be equal to negative 2 over 5. And my point, my x1, y1, are they the same?
Yes.
Yes, so we didn't need to change those, so my x1 and y1 are the same. Now I'm just gonna go plug them in. So now I've got y minus 3, like I had before, and in the place of the slope, I've got negative 2 over 5, and then I've got this x minus, and my x1 was a negative 2 still. Alright, so I plugged in my slope and my x1, y1. Now I'm just going to simplify and get it y by itself like we did before. So now I've got y minus 3 on the left equals negative 2/5 times x. It's going to be a plus 2 again, right? That stayed the same. Distribute the 2 over 5 to everything inside the parentheses. So I've got 2/5 x plus 2/5 times 2. Put a 1 underneath this one. Alrighty, so I've got y minus 3 on the left equals 2/5 x. Now, some math I've got to do here. I've got 2 over 5 times 2 over 1. I'm going to multiply straight across the top and straight across the bottom. 2 times 2 is 4, and 4 times 1 is 5. Do I have y by itself yet? No. What should I do to both sides to get rid of this minus 3 over here? Yes, ma'am. Yes. Thank you. Y'all didn't catch my mistake? You caught my mistake. All right, so here's the mistake. This negative right here, should I have distributed a negative to everything here? Yes. All righty, so let's fix it. So this should be a negative, that should be a negative. Now, this should be a negative right here. And that's going to turn this into a, look right here, that's a negative sign. So I've got a negative 2 and a positive 2. So negative 2 and a positive 2 should be a negative. So that should be a negative 4 over 5. Y'all check my math. Does that look right now? Y'all, so y'all think? Okay, because the only thing I did from here to here was I did that negative and that negative became a positive. I didn't touch this one yet. So now we come down through here and make sure all my signs are right. Now should I add 3 to both sides? Yes. Okay, add 3 to this side. Come over here and add 3 to that side. And I now have y is equal to a negative 2 over 5x. I've got some fraction math to do off to the side on my scratch paper. So I've got negative 4/5 plus 3. All right, so negative 4/5 plus 3 over 1. I need a least common denominator. What's the least common denominator for 5 and 1? 5. So I need this bottom to be a 5. This denominator gets a 5. So I'm going to multiply the bottom by 5. What you do on the bottom, you always have to do on the top. So I'm going to multiply the top by 5. So now I have negative 4/5 plus, what's 3 times 5? 15 and 1 times 5 is 5. So now my bottoms are the same, my denominators are the same now. So you can multiply, you can add the tops. Negative 4 plus 15 is 11 over, is that right? Okay, so now we can finish that equation. So, what's the equation of the perpendicular line? Y equals negative 2 over 5 times x plus 11 over 5. So I just took that and put it here. Questions?
So, and this is our perpendicular.
This is what you do for perpendicular lines. Perpendicular lines.
And so if we wanted to know the slope of the opposite line, we just turn it over and make it a positive 5 over 2x, right?
So it depends on what the original slope is. So if the original slope is positive, your other slope is gonna be negative. If the original slope is negative, then you're gonna flip it to a positive. Okay? So again, the first one we did was for parallel lines. The second one we did was for perpendicular lines. All righty, let's see. All righty, they did the process. They got the same answer we have? They did. They skipped some steps, but we got the steps on the board here. All righty. Real life. Are you ready? We only got two slides to do, and then we're done with all of chapter 1. Can you believe it? Yes, we have finished all of chapter 1. All right, what we're supposed to do every time you get to a word problem first? Read the problem. Now, you do know that we're going to apply what you just used here, right? Some of the information, it may not be everything all at one step, but are we going to use some of what we did today?
Yes.
Absolutely. So let's read the problem thinking about, okay, she's going to make us use what we just learned in the last 30 minutes. All right, so a company charting its profits notices that the relationship between the number of units they sold, which they call X is the number of units sold, and the profit, which we call P, they notice there's a relationship between how many you sell and your profit. Isn't there usually a relationship between how many you sell and your profit? Yes. So they said if you sell 300 units, how much money did you profit? 4,650. If you sell 375 units, how much money did you profit? 9,000. Okay? Now, think of it as input and output. Did they give you some points? Did they give you some input and output?
Yes.
Yes, they did. You got to look at what they gave you. In the problem, did they give you some numbers?
Yes.
And I need to know that you see those as input and output. Tell me what the input is for the first set of numbers you see. Here's input. And here's output. All right, here's the dryer. Something going on inside of here. What's happening inside of here?
300.
Okay, you said put 300 in. Right now I'm going to call these X and Y. I put 300 in because I sold. What you get out? $46.50 in dollars, okay? And what's happening inside of here? How do you end up from here to here?
You selling.
You're selling some stuff. People coming in buying your stuff. So all this is in here, people buying stuff. Something's happening, people buying stuff. What else did you get?
375.
So you sold. The input is, again, let me put, this is what's sold. And this is the profit. Profit. Alrighty? So 375. What was the profit?
9,000.
Alrighty. 9,000. So can you see that as input and output?
Yes.
So with that said, can you also see these as X and Y and X and Y?
Yes.
Can we label them like this? Can we call it 300, 4650? And we call this one 375, 9,000. Can you rewrite them like this?
Yes.
Sure. Now they gave me two what? Points. So you got an X1 and a Y1 and an X2 and a Y2. What does it say? It wants you to do in bold.
Right Write the equation.
And what did we say you have to use if it says write the equation? Aha. Did they give you enough information so you could use the point slope formula?
Yes.
All right, here's my point slope formula again. All right, so I got to fill in my slope and my x1 and my y1. We don't have a slope.
We have to find.
Well, wonder what we going to do. What we going to do?
Find the slope.
How we going to find the slope?
And y equals the next.
Aha, so you got to go do the slope formula. Y2 minus y1 over x2 minus x1. Alrighty, so you know what your x2 or your y2 and your y1 are. So my y2 is 9,000 minus 4650 over x2 is 375 minus 300. All right, y'all, help me do the math. What's 9,000 minus 4650? 50 here.
So three.
3. Is that 4350?
43.
Is that what you got, 4350? And 375 minus 300 is 75. Somebody do this on the calculator. Tell me what 4350 divided by 75 is. 58? Okay, so that's 58. Now, let me say this real quick. The Y values represent what in this particular output? And what's the topic? Profit, okay? And profit is always going to be in dollars, okay? So up here is dollars. What's on the bottom here? These are dollars. What are these things down here underneath on the bottom?
The amount sold.
Units that you sold for each one. So, okay, this is for each unit. So you got dollars up here, and this is per each unit. Okay, just making sure we understand. This is per unit. This is dollars per unit. Okay? This is, yeah, units sold. You can put it here, units sold. Okay, all righty, you got it? So, if somebody said, what goes with it, because in the homework, it's going to say 58 what? And you can be like, $58. Well, $58 what? It's $58 per unit sold, or per item sold. Just like when we did, remember we did the one about the plumber at the house? Aren't you being charged $30 per hour? So this slope is always going to refer to something per something. So it's either going to be units sold per hour, per day, per something. You got what we're saying? So this is $58 per unit sold, or each one that you sold. So you can write it this way, or you could write it with the slash. You know, it doesn't matter. Just making sure that you understand this is $58 per unit sold. So on average, that's how much money they're making for each one. Alrighty? So what were we trying to do? Okay, so we needed the slope. So we do we have the slope now?
Yes.
$58 for each unit sold. So I'm going to replace M with 58. Do I have X1 and a Y1?
Yes.
Yes, so I'm going to plug in my Y1 is we labeled it already as the 4650. And my X1 is 300. All righty. Now we're just going to do the math and get what? What we trying to do the math and get what by itself? All righty. So, all right, let's do the math here. So we got 58 times X and 58 times 300. So I do the math for me. What's 58 times 300? Say it again. 17,400. All right, so I've got Y minus 4650 on the left side is equal to 58 minus 17,400. How do I get Y by itself? Add 4650 to both sides. The 46 and the positive and negative 46 on the left side cancel. So I have Y equals 58X minus, somebody do the math for me, what is that going to be? 12,000 what? 20. You end up having a negative and a positive. So it should be negative 17,400 plus 4650. It should be a negative 12 what? 750? Is that what everybody got? Did y'all all get that? You need to check it. All righty, what did you just create? An equation based upon profit of what you sold. So why would you ever need this? If you own a company and you're trying to figure out what's my average profit gonna be, and you wanna know if I sell, again, this may be 1 day's worth of sales, and here's another day's worth of sales, and you're like, well, what's my equation I can predict the sales for any day? Depending on how many I sell, that's what you need the equation for. Whenever you read the equation, could you see that they gave you two points automatically using the information that they gave you? Yeah. All righty, so let's see, last one. Here we go. A business uses straight line depreciation to determine the value, which is Y, of an automobile over a 5-year period. Suppose the original value, which is when T is 0, is equal to 26,000, and the salvage value when T equals 5 is equal to 1,000. All right, we got to read and make sure we understand the problem. First of all, didn't we say you got to understand all these words in the problem?
Yes.
All right, straight line depreciation. It means that it loses the same amount of value every year. Straight line depreciate means loss of value, right? So straight line just means it's the same amount. You're going to lose the same amount off I mean, doesn't a car depreciate as soon as you drive it off the lot? Exactly. So every year your vehicle depreciates. In this particular case, they're saying it's depreciating the exact same amount every single year. You got it? All righty. The salvage value is the value after those years are over. So they're saying T equals 5, meaning 5 years after you done bought the car, 5 years later, what's the value of the car 5 years later? $1,000. It's a sad thing when you done spend $26,000. Okay? So, they want you to write, what did it say right now?
The linear function.
Is that the same thing as write the equation? Yes. Remember, I use function and equation interchangeably. So yes, if it says write the equation, write the function, same thing. Alrighty. Now, in the homework, is it always going to use X and Y? In this case, they're using T and S. T is your input, S is your output. T is how many years, S is how much it's worth, the salvage value. You got it? So that's what I mean, you got to make sure you understand every single word in the problem. T in this case is time and years. Salvage value is what it's worth. So let's draw some pictures just like I drew you this input-output picture for this one. Let's do the same thing for that one. So did they give you enough information for you to have 2 points? That's what you got to be able to see. So let's do our input-output table. So here is my input-output table. So here we go, input and output over here. Something goes on inside of here. All righty, so input, what's going in?
0.
And you've got 1 to 0. So when you put 0 in, and remember the input was the years. Let me make sure what it says. Okay, so now here's what you got to know. T is representing the year at the time that you have it. Okay, so this is year. So this says that 0 years, which means you just bought it. Okay, so I'm going to write here, you just bought it. So this is year 0. And how much is it worth when you just buy it, when you just sign the papers?
$26,000.
$26,000 is the value, so we're going to say salvage because that's what they're calling salvage, is the value now. Okay? So for 0 year, you just bought it, it's worth, the value now is $26,000. Okay? So that was my output. What's my other input? They gave me some more numbers.
5.
Okay, so now this is 5 years, is input, and what pops out?
$1,000.
Okay, because now the value is $1,000. Now, instead of X and Y, what letters of the alphabet did they use? T and S. So that's what you gotta use, because if you don't use TNS, they're gonna mark it wrong, even though you know it's right. Alrighty, so do I have enough information to create some points?
Yes.
All right, what's my first 2 points I'm gonna create?
And 26,000.
Okay, and what's my second point?
5,000.
And 1,000. I'm gonna label them X1, Y1, and X2, Y2. Can I go find the slope?
Yes.
Okay, well, let's go do the slope. So M is equal to Y2 minus Y1 over X2 minus X1. Let's just plug them in. So I got 1,000 minus 26,000 over X2 is 5 minus 0. All right, so my slope now is, let's see, that's 1,000 minus 26,000. Is that negative 25,000? Over 5. So that M is going to be equal to a negative 5,000. So my slope is a negative 5,000. Should that be an uphill line or a downhill line? Downhill. Why should it be downhill based upon just the logic of the problem?
Because it's depreciation.
It's depreciating. It's going down in value, so the line got to go down. It's got to be a downhill line. Alrighty. So do I have enough information at this point to do my point slope formula? Do I have a slope?
Yes.
Do I have a point?
Yes.
Okay, now let's go put it into the point slope formula and see if we can work it out. So here is my point slope formula. Alrighty, so now I'm gonna replace my X1, Y1 with, over here, this one is 0. There's 0 for my X1. What's my Y1? 26,000? 26,000 goes there. Alrighty, you good so far? Do I need to plug in my slope? What was my slope? Negative 5,000. So I'm going to put a negative 5,000 right there. There's my parentheses, X. Alrighty. Alrighty, I put in my slope and my point. Let's solve and get X by itself. Okie dokie, so let's see. I've got negative 5,000 times X. And then I've got negative 5,000 times 0. What's negative 5,000 times 0? Okay, so let me just make sure you're okay with, I did this and I did that, and I got a 0. Did I really need to write that 0? No. All right, so I'm just going to put down here 5,000x. Over here on the left, I haven't done any work on the left yet. So I'm just rewriting what I already have on the board. So I've got y minus 26,000. And I know it's time to go, so I'll finish this one and then you guys, we're done. All right, I need to get y by itself. What do I do?
Add 26.
Add 26,000 to both sides. All right, the 26,000 and the negative 26,000 cancels on the left, so I have y equals negative 5,000x plus 26,000. That's the equation for depreciation of the vehicle. That is the equation for the appreciation of the vehicle. That's the linear function used to determine the value of the vehicle at whatever year. Alrighty, that finishes up chapter 1.